Hey guys, anyone who's ever watched any of my explainer videos knows I love to talk weather. I love to explain the how and the why, the processes of how we get there. It helped me when I was growing up to understand things. It made things easier to comprehend and not be afraid of. One of the cool things about being a meteorologist is there's a lot of things that fall under that umbrella of Earth science. And one of those happens to be, geology, plate tectonics, seismic activity, how all of that works. We had an earthquake on Wednesday afternoon, and it was very close to the Aleutian Islands, just south of Sandpoint, Alaska. And that's what we're going to talk about today. Kind of walk you through it, what happened, what was the result, how common is an occurrence like this. So let's start with just kind of an overview of this is a sample size, okay? It's only 5 days, but this is looking at earthquake activity across the Pacific Rim over the last 5 days. And basically everything of a magnitude 3 and higher is showing up here. Obviously, you see, there are a lot. Earthquakes are very common along these fault lines, and we happen to have one out in the Pacific, and these can be almost a daily occurrence anywhere along these boundaries between plates, and the strength intensity certainly varies, but it is a common occurrence. So that's kind of step one with this from a wide angle lens to give you an idea of what we're looking at. So let's go now to what happened. This was Wednesday afternoon. This was, if you go to Alaska daylight time, it was 12:38, so just after lunchtime. This is a look at the Aleutian Islands. I've got Sandpoint, Alaska, a little bit bigger than the rest, just to kind of point that out. But a 7.3 magnitude earthquake occurred at this time. And to give you an idea, the Richter scale goes to 10. This was a 7.3 out of 10. So you can do the math. That's relatively high, and certainly got the attention of folks in that part of the country, scientists as well. So tsunami warnings were initially issued. They got downgraded to advisories once the event began to unfold, and ultimately the advisory that was still in place was allowed to be canceled by 2:42 local time. So the tsunami warning went out as a result of, picking up on this pretty significant earthquake taking place just offshore, due south of Sandpoint. Good news, there were only slight fluctuations in water height around the islands. There was, near Sandpoint, I believe, there was a 0.2 or 0.2 of a foot rise in water, called a tsunami technically. But the impact certainly could be worse, especially when you look at the significance or the strength of this particular earthquake. Here's something interesting, though. Let's go back, same day, 2023, July 16th. How about this? A 7.2 magnitude earthquake on the same day, in the same location, just 2 years earlier. I just thought that was interesting. Again, it's along an active fault line, so it kind of makes sense. But for it to be a very similar magnitude, location, and of course day, I just thought that was interesting to throw in there. So that was on same day in 2023. All right, we're gonna go back to the wide angle view. So for those who don't know how the plate tectonics with our planet work, the largest outlines the Pacific Ocean. So we are looking at the Pacific Ocean. You can see Alaska off in the northeastern corner. You've got Japan, the Philippines on the far western side of the screen. You can see Hawaii there in the midst of the Pacific Ocean. All of those areas I just mentioned are either part of or bordering up to the Pacific Plate. It is the largest plate on Earth, and it basically is the entire outline of the Pacific Ocean extending into the southern hemisphere. This part that we're looking at here in the northern hemisphere, you see where there's blue depicted there? That is a convergent boundary. So what that means is you've got a plate, being the Pacific Plate, that is nudging towards other plates. and the European plate is off to the north and west here. The North American plate is to the north of the Pacific plate near the Aleutians. And as the Pacific plate moves, I mean, we're talking millimeters, centimeters. That's a convergence of boundaries. It creates a subduction area, and ultimately these tiny rifts between these plates, as one pushes underneath the other, as the Pacific plate does, you get these disturbances, these earthquakes that lead to various impacts and results, both with location, length, and magnitude. So the part that we're looking at here, it's all convergence. You can see some other lines depicted here with other plates that are green. Those would be divergent. So the exact opposite. That's where one plate is moving away from the other and it's creating a void. Very small, but over time that leads to trenches on the ocean floors. The Atlantic Trench is one where former plates pulling apart, it causes that void or that gap. So that's kind of a background of the different boundaries, how they work. There's one more, and that's a transform plate. So if you're not going together, not moving apart, you're kind of moving horizontally next to each other. So a transform, imagine two objects next to each other kind of slipping in either direction. You can also get earthquakes from that, and that's a very common boundary along the west coast of the United States, which also connects to the Pacific plate. So the Ring of Fire, you probably heard this. One of the other aspects of these subduction zones, these where the plates diverge, is you get volcanic activity over time. As these there's subduction occurring with the plates, you'll have magma come up, and you'll form these volcanic islands. And that's what the Ring of Fire is. It's volcanic islands that surround the perimeter of that Pacific plate. It goes all the way down towards South America, all the way up over the Aleutians, and back towards the Philippines. And this accounts for 75% of the total volcanoes on Earth. So pretty significant. Again, it just goes to show the size, the magnitude of our Pacific plate and what all it can bring about. So focusing now on the Aleutians. Again, we talked about it's a convergent boundary. You see that. And the islands are right along this. Some interesting stats here. We just talked about the amount of volcanoes that the entire Ring of Fire accounts for. How about this? 27 of the 65 active volcanoes in the United States are found here. So that's a pretty significant number. That's historically active volcanoes. So this is considered a seismically active area, and we saw a perfect example of that on Wednesday when the earthquake occurred there just to the south of those islands. So let's go back and take this by the numbers. So I first went back and I just did 40 years. Seemed like a nice round number. Go back to 1985. Then I filtered out magnitude. So this would be basically high-end earthquakes that have happened since 1985 within the Aleutian Island chain and region. Only 20 occurrences where a magnitude 7 or higher earthquake has happened. You look at that over 40 years, pretty spaced out. That's not a ton over a 40-year period. Nevertheless, there have been plenty. So looking at this more specifically, this is called the Aleutian Fault. Again, it's part of the greater Pacific plate, but labeled the Aleutian Fault here, and it's also part of the Aleutian Arc. That's what you call this whole area of that fault line, and you can see how it lines up with the islands. It's the same shape. It's how these islands came about. And within this Aleutian Arc, you'll have pretty active seismic motion, activity. And that, of course, as I talked about, has led to numerous earthquakes. I went back, period of record, which is 1884 to now, and there's been over 200,000 earthquakes in this part of the world, documented by the U.S. Geological Survey. But we're just looking at a smaller sample size to show kind of the significance of this. So look at this. This goes back to what I talked about at the beginning. July 16th of 2023, July 16th of 2025. These are the two plotted instances, one being the 7.2, which was in 2023, and then the more recent 7.3 magnitude, which just recently happened. Look at that, 16 miles difference. So just thought that was kind of interesting to put in perspective. These can happen anywhere along that fault line, and sometimes in the same place, very close together. So again, that all happening within a 2-year span, going back to 2023 at a very similar magnitude. Speaking of magnitude, this again, we're looking at the Aleutian Island region and the earthquakes that have occurred within that region. So now we're going back period of record. Going back to 1884, within this whole segment, taking out everything below a 7 in magnitude, there have been 69 recorded earthquakes. Since 2000, that's an easy dividing line, there's been 13. So over 25 years, we've had 13 occurrences where there's been a magnitude 7.0 or greater within the Aleutian Island region. The strongest during that period was back in 2021. That was an 8.2 magnitude, so a good bit stronger than what we had just the other day. But that was just a couple years ago. We had one that was very strong there. So let's go look at some of the numbers all time. So you're going to see here some numbers left out. That's because there's ties on this list. This is the all-time ranking within that area I just showed you. And the strongest came back in 1965, February 4th, the Rat Islands region, an 8.7 magnitude. That is a common location. If you were to go down this list within the Aleutian Island chain, you'll see Rat Islands pop up several times. It makes sense. The whole area is active, so if it happens one time, why can't it happen more than once? The Alaskan Peninsula is also another region or specific location where there's been several, and you can see tied for 5th on that list an occurrence in 1938, and then the aforementioned strongest occurrence since 2000 was that 2021 instance that happened on July 29th, magnitude 8.2. So I went down the list, and eventually I found the one that just occurred, Sand Point. And that is tied for 28th all-time as far as magnitude. And this is going all the way back, including all earthquakes, to 1884 in this region. So all the earthquakes that have happened, 100 plus years. It's the 28th strongest, tied for that anyway. So takeaways with this. Is this uncommon? Absolutely not. We see different levels, intensity, strength, magnitude, if you will, earthquakes in this part of the world all the time, really all along this fault line. Is the magnitude or strength a bit of an outlier? Sure, you could make that argument of all the earthquakes that have happened over time. This ranks in the top 30 of all time. So yes, it was a strong earthquake. It was one that prompted those tsunami warnings. Fortunately, there was no major impact from that, and that is always good to hear. But you look all time, and even recently, there have been occurrences of this magnitude. So these are one of the hardest things to predict. The USGS is a group that looks for things, and a couple things that they look for, and geologists and scientists associated with this field in plate tectonics look for are tremors, or just before a major earthquake, sometimes you'll get a lot of smaller magnitude earthquakes, and that's what they look for. So fortunately, we have folks who are really good at this and detecting it, so there can be good warning. And thanks to the entities that put out these warnings, advisories, letting folks know that there was indeed a tsunami warning and advisory in place, on Wednesday, the 16th. But again, earthquakes, one of those things that happen. They're a part of our planet, part of how it works. And I just hope to not see these strike in an area where, you know, they can do some real damage, with whether that's just the earthquake itself or a resulting tsunami. So that's a little bit on plate tectonics, the Pacific plate, and kind of how things work. It's fun talking about that. I certainly love discussing this sort of stuff, trying to be a scientist and kind of get through all this. Hopefully you learned something, had some fun. See y'all next time.